Okay, good morning, all of you. Okay, up to this, we have finished in the last class. Now we are going to start question number 4. Do you hear me? Okay. Yeah. So this is the circuit given, which contains resistance R, inductance L, and capacitance C. And the question asked is find V of t when t is greater than 0. The switch moves from position A to position B time t equal to 0. From A to B. Before t equal to 0, the switch is connected like this. Capacitance is not connected. Now, find the value of first V of 0 when the switch is connected to A. So, the current we are going to find the current. L of 0 equals the total current. This is the total current. So, this will be short circuited. The switch is connected for a long time. Then inductance becomes short circuit. So the current will be V by R. V is 220 and R is 30 plus 10. IL of 0 will be 0.5 ampere. Is it clear? Then the switch is moved from A to B. Then it will be free running circuit. Free response of RLC. Okay. And find the value of, this is the procedure. Just find the value alpha and omega naught. When alpha equals R by 2L, you will get 1.25. Omega naught equals 1 by root LC, you will get 1. Now alpha is greater than omega naught. So we have overdamped case. Circuit is overdamped. Why? Because alpha is greater than omega naught. Find the roots. S12 equals, this is the formula, plus minus. So you will get minus 0.5 S1 and S2 as minus 2. Now when the two roots are negative and the two roots are negative and real, not real. Okay, real means 1 2 3 4. So the there are two roots and both are negative. Then we have a circuit which is overdamped. We have this formula: A e power S2t plus B e power S1t. Now substitute the values of S1, S2. S1 is 0.5, S2 is minus 2. Minus 2 minus 0.5. Then this is the standard equation you got. To find the values of A and B, we substitute in the place of t equal to 0. You will get this equation, A plus B equal to 0. Now by using this, the value of IC of 0 equals 0.5. You got this. IL of 0 equals to 0.5. By using this, now IC equals C dV by dt. So IC of 0 equals to C dV of 0 by dt equals 0.5. This IC of 0 equal to 5. We got IC of 0, IL of 0, both are same. Okay? 0.5. Now dV of 0 by dt equals 0.5 by C. C will be cross multiplied here, equals to 2. The value of C is given 0.25. Then dV of 0 by dt will be equal to 2. This value of dV of 0 by dt equals to 2 set aside. Save. Now differentiate the equation. The first equation, the standard equation. Differentiate this. Okay. It becomes dV vt by dt, dV of t by dt equals a into e power minus 2t multiplied by minus 2 plus b e power minus 0.5 t multiplied by minus 0.5. Differentiate like this. You'll get this. Now substitute t equal to 0 again in this differentiated equation. You'll get one equation, that is equation 3. Now by using this equation, what is this 2 dV of t by dt equals to 2? You got here. Substitute in this place. You got equation 3 and equation 2. Equation 2 is a plus b equals 0. And by using these two equations, you will get the values of a and b. Add, subtract. You can use matrix method. You can use any way. Okay? Translation method and substitution method or matrix method. You can use any method to get the values of a and b. Got this. Substitute in the first equation. This is the final answer for this. Understand? Okay, thank you. Now we will move for. Okay, thank you. Now we will move for number 5. Next question. You can have the sheet. This is sheet number 3, I think. 3 or 4? 3. Now this is the next question. In this question, it has been given the voltage of the circuit and voltage of the capacitance, and current through the inductor is given. Okay. Given. So by you can observe in this equation here the two roots S1 S2 is given. You can consider this is S1, this is S2. You can consider it like this. Okay. And here also the same S1 S2. The roots are given. Okay. That's why we can given the roots. S1 equals minus 10, S2 equals minus 20. And what is the question here? The voltage determine the values of R, L and C. This is the question actually. The equations for voltage and current are given. You have to find the values of RLC series. Okay? RLC series free response. Now this is the formula for this is the formula S12 minus alpha plus or minus under root alpha square minus omega square. These are given equals minus 10 minus 20. Either by using the equation you got this S1 and S2. If you add these two roots S1 plus S2 equals minus 2 alpha. Okay, this value and this value will be cancelled. Plus minus under root alpha square minus omega square will be cancelled. You will get minus alpha minus alpha. It will be minus 2 alpha. Just a minute. Okay. So these are the formulae of alpha. Alpha equals R by 2L, and then R equals alpha into 2L. Okay. What is alpha? Alpha is now R equals 30L. Got this. Set aside. Using this, you got alpha equals 15. So R equals 15 multiplied by 2L. Substitute just the values of alpha. You'll get R equals 30L. This is equation 1. We did not got the value of R. It contains L also. Now S1 equals this. You don't know the value of omega naught. By using this equation, you got omega naught equals 25. Now omega naught equals no S1 equals this equation you got. S1 is minus 10. After substituting, you will get omega naught equals 14.14. Now the formula for omega naught is 1 by root LC equals under root 200. LC equals 200. This is one of the equations. Now you got two equations for R and LC. Okay, these two. Since RLC is series circuit, IC equals IL equals C dVc by dt. In series, current through capacitor and current through inductor will be same. And this is the equation for capacitance. Now integrate this, substitute this VC here and integrate. You will get, after integration, IL equals this equation. Now substitute the value of IL here. IL is given in the question. VC is differentiated and IL substitute. You will get the value C here. C. After getting the value of C by using this procedure, substitute the value in equation 2. L equals 1 by here the equation first. LC equals 1 by 200. Substitute the value of C here. You will get the value L. After getting the value of L, substitute that L here. You will get R. Is it clear? Now you got the values of C, L, and then R. Is it clear? Okay, thank you. Now we'll go for next question. This is also simple. It seems the same circuit, but the procedure for this will be different because here the equation is not given. R, L, C are in the series. Okay. In the place of R, you have these two resistors, 60, 40. So shall we do this problem or it will be homework? This is also simple circuit. So that we can go for next circuit. RLC parallel. Okay. RLC's parallel is finished. in theory? Excuse me, anybody there? Okay, RLC parallel is also finished. Okay, so this question, you have the solution, in the sheet, but clearly explain and submit me as homework for this question. This question number, what is this question number? I will tell you. Wait a second. Wait a minute. This is question number 6. So question number 6 will be homework, and we will go for question number 7. Question number 6 will be homework. Okay. Okay, I will do. Message on the ads means announcement. Okay, I will give announcement, as well as I will check the assignment marks, and I will give in the blackboard. Okay, in grade center you can check the marks after 2 to 3 days, or in the next week I will give the marks. Okay, now we will start uh, parallel. RLC parallel. Three response. Okay, this is the question. Question number 7. So question number 6 will be homework. I will give a message. Now for parallel, these three are parallel. Okay, and the switch is open after t equal to 0. T equal to 0. When t is greater than 0, the switch is open. It is free response without source. Now before t equal to 0, the switch is connected to the source. Okay. Now find the value of omega naught and alpha. Same formula we have here, but the formula for alpha is different here. 1 by 2 RC is the formula, and omega naught is 1 by root LC. Omega naught is same, alpha is different for parallel. Now for underdamped, omega equals this formula. Okay, why underdamped? You got the value of omega naught equal to 2, alpha is 0.5. Alpha is less than omega naught, circuit is underdamped. For underdamped, omega d you have to find. Okay, then the after finding omega naught, omega d damped value equals 1.936. Okay, but find omega naught, omega d. So I of 0 equals initial inductor current equals 20 by 5 equals 4 ampere. How you will get this? 20 by 4. Understand this? I equals V by R. What is V? V is 20 and R is 5 plus just 5. Okay, so now when t is greater than 0, when t is greater than 0, when t is less than 0, this circuit is connected and this inductor becomes short circuit, capacitance become open circuit, and 1 ohm resistance will be present, but whole current will be passed through the inductor. That's why the the current through the inductor, okay, IL will be 20 by R. What is R? Just 5. The current will not pass through this 1 ohm resistance. Does the current pass through 5 ohm and short circuited inductor? That's why 20 by 5. Understood? So you will get I of 0 equals 4 ampere. And VC, voltage across the capacitance, equal to 0. Okay? Why? But understand this. Because there is only short circuit here. When it is short circuit, the voltage will be 0 here. Okay? Here, the whole voltage will be at 5 ohm resistance. Okay? Here, since it is short circuit, that's why capacitor voltage will be 0. Just clear? Then coming to the equation. For underdamped circuit, for underdamped parallel circuit, this is the equation, standard equation for parallel RLC circuit. Okay? Now substitute all the values here. Alpha you got the value of alpha, that is 0.5, and A1 you don't know, you have to find now. And omega d under damped value omega d is 1.936. Substitute here. Here also substitute. And substitute t equal to 0 to find the values of A1 and A2. You will get A1 equal to 0. Then integrate the standard equation. This is after integration. Now after integration, substitute equal to 0, you will get equation 2. Substitute value of A1, you will get A2. Okay? dV by, now you got dV of 0 by dt equal to this equation. Okay? Now IL plus IC plus IR equal to 0. This is the standard equation. You have to use this. IL equal to 4. You got C dV by dVt, V of t by dt. IC equals this value, and IR equals V of 0 by R. This is the standard equation. Substitute the values equal to 0 here. Okay? C is given, and dV of 0 by dt you have to find. This is not given. Okay? So finally V of 0 by R equal to V of 0 equal to 0. You will get by this equation, by this standard equation, you will get the value of dV of 0 by dt, that is equal to -4. Substitute this V and dV of 0 by dt equal here. Substitute here. After substitution, you will get the value of A2. A1 is already you got. Okay? You will get the value of A2. And substitute A1 and A2 in the standard equation. You will get the value of V of t. Is it clear? Understand or not? This RC, RLC parallel. I'm going to the next question. This is also RLC parallel. Excuse me. Nobody is giving a response. Hello. Okay. Understood? Okay. Then going to the next question. Question number 8. This is the circuit given. RLC parallel here. Here is the switch. The switch is closed before t equal to 0. After t equal to 0, the switch is open. And it is also free response. Why? Because after t equal to 0, there is no source, no independent source. So you can find the values of IL, VC. This is also the same procedure. So IL of 0 equal to 3 ampere. How? The same. This when t is less than 0, the switch is closed, capacitor is open, inductor is short circuit, and the value of current will be this. The value of current will be 3 as it is. Since the current will not flow through this, the current will flow from short circuit of inductor. That's why the IL of 0 is 3 as it is. The same source will flow like this. Okay. Now VC of 0 equal to 0. Okay. Here short circuit, then the voltage across this will be 0. When the switch is open, t equal to 0. Okay. The switch is open. Find the value of alpha and omega naught. To get the condition of the circuit, whether it is underdamped, overdamped. Okay. Alpha equal to 6.25. Omega naught is 5. So alpha is greater than omega naught. The circuit is overdamped. Alpha is greater than omega naught. Okay. Then you have the formula for V of t. V of t equal to this formula. Same formula as in series RLC. Here also the same formula. But the value of omega alpha is different. Okay. For RLC. For series it is different. Okay. And standard formula for voltage is same. Okay. We have two roots, S1, S2. Substitute the values of alpha and omega naught. We will get S1 as minus 2.5, S2 as minus 10. Then substitute in the standard equation P of t. This is S1, this is S2. Substitute equal to 0. We will get one equation. A1 equals 2. Now differentiate the standard equation. Substitute t equal to 0. We will get this equation 2. Now using the standard equation, IL plus IC plus IR equal to 0. Here IL is 3 you got, and C dV of 0 by dt, this is IC, plus IR equals IR is V0 by, here it is not 20, okay, just V of 0 by R, okay, here the same, it is not right, and V of 0 by R will be, VR is 0, that's why here it is 0, okay, and substitute the value of V of dV of 0 by dt here, this is complete, dV of 0 by we got here, substitute here, and C, what is C? 4 millifarad, okay, 4 millifarad, milli or what? Value of C is given 4 millifarad, okay, so 4 into 10 power minus 3, this is capacity, and the value of I, that is V of 0 by R, V of 0 is 0, substitute here 0, here it is not 20, okay, here this value is V of 0 by R, what is R? 20. Here is a small mistake here, here it is a mistake, okay, after substituting, so V of 0 by R will be 0 by 20, it will be 0, After substitution, you will get the value of A2. Okay, substitute A1 equals to minus A2. You will get the value of A2 here. Now A2 equals to 100, A1 equal to minus 100. Substitute in the standard formula, you will get the value of P of T. Is it okay? Understand? Okay, thank you. Then going to the next question. This is question number 9, I think. It's also simple subject question. This is the last question or what? I have one more. This is the last. 2 more questions we have. Okay. We will see the both of them. So this is the question number 8 or 9, I think. 9, I think. Determine the value of V of T is greater than 0. We have here RLC. Now find IL of 0 equal to 0, because when this source is connected 8 volt, this for a long time it is connected to one source 8 volt. So this capacitance will be open. That's why capacitor current is 0. Sorry, inductor current is 0. Inductor is short circuit and capacitance is open circuit. That's why current will not flow. That's why it's equal to 0. And VC of 0 equal to 8. Because 8 is connected here. The whole current will, the whole voltage source will appear here across the capacitance. This is standard. Now, when t equal to 0, this is series free response. Okay, that's what I said. Series free response. When t is greater than 0, then also the source is connected to 12 volt. Find the value. Force response. Sorry, RLC series force response. Why? Because source is connected. Okay, this is important question. Find the value of alpha and omega naught. Alpha is 1 and omega naught is 2.23. Alpha is less than omega naught. So it is underdamped. Underdamped, omega d equals to, and this omega d. The formula is same. Okay? Underdamped, the standard value is same, but here we have Vs also. Okay? What is Vs? Source motion. Source is present. That's why Vs. It is force response. That's why we have to add this Vs plus this standard equation. Understand now? This is same as series free response, but it is force response. That's why we add this Vs here. Okay. Substitute the values of omega d here. Okay. Omega d equal to 0. Substitute t equal to 0. You will get one equation. A1 equals minus minus 4. Then differentiate this. Differentiate the standard equation and substitute the value of equal to 0, you will get dv of 0 by dt equals 4 plus 2a2. You will get this equation. Now IL of 0 equal to c dv of 0 by dt. You will get a2 equals, substitute value of v and dv of 0 by dt. This value, substitute here. You will get a2 from this. IL of 0 is 0, found at the first. Now substitute all the values in the standard equation. You will get v of t. Okay. Here 12 is source. Is it clear? Okay. Then coming to the last question, this is parallel. Okay. The switch is here, and the switch is closed. This will be parallel RLC. And the switch is on, then also it will be parallel RLC, but this resistance is connected in series. This parallel LC and R. This will be in between. And T is less than 0. When T is less than 0, this resistance is present. When T is greater than 0, this resistance is not present. It will be parallel RLC. So we will find V of 0 first. T is less than 0 means V of 0. V of 0 is 0. As you know, the source is connected, then it will be short circuit. That's why Vc of 0 will be 0, and IL of 0 equal to the total current multiplied by this resistance. Why? Because we are finding this current. So opposite resistance by total resistance 10 and 5. Okay, it is open. This is opposite resistance. This is opposite resistance. This is the same resistance. This is opposite resistance. So opposite resistance by total resistance. 5 by 5 plus 10. This is total current. And T is less than 0. Okay. T is less than 0. This resistance is present. That's why we got A of 0. Now, after T equal to 0, the circuit will be like this. Okay. When T is less than 0, the circuit will be like this. When T is greater than 0, the circuit will be like this. Okay. This is short circuit. Find the value of alpha and omega naught. Both the values are same. The condition for the circuit is critically damped. We did not do this problem. Critically damped. So RLC parallel, critically damped. Okay. And force response. Here the current is IS. Force response, you have to add the source here. That's it. As we did in the last problem. Okay. Now the standard equation is this. For critically damped, A1 plus A2 of t multiplied by e power minus alpha t. Why we don't have alpha naught, S1, S2 we don't have. Why? Because it's critically damped. Alpha is equal to omega naught. That's why we don't have any S1, S, only S we have. That's why we have like this formula. Let's substitute the values IS, N, alpha or omega naught. Both are same. That's why minus 10. Substitute equal to 0. You will get A1 equal to minus 2. Differentiate the standard equation. This equation. You will get this. Substitute equal to 0. you will get di of 0 by dt equals 20 plus 2. Now Vc equals Vl equals L di by dt. Now L di by dt, di of 0 by dt, substitute this value. Here you got, substitute this here, get A2. Okay? After getting A2, substitute in the standard equation, you will get I of t. Okay? If you want to find V of t, then L di by dt gives you V of t. Here now, finish for today. Okay? We have finished sheet 3, which contains series and parallel RLC, free response and forced response. Is it clear? Then we will start in the next week phase circuits. Okay? Finish for today. I'll give you the homework. Thank you.